Hey, hello guys, welcome, vanakkam, vandanam, namaskaram. In our last part, we have seen till here, where we have seen about what is a Daniel cell, what is a galvanic cell, what is a voltaic cell. Voltaic cell is the name of chemical cell. Okay, you can just note it out. See, if I miss voltaic cell, okay, if I miss one or two points in some of my videos, then those points will be mostly they will be covered in the next upcoming videos. So I will try my level best to give as much as information as possible. Next is IUPAC representation. This video won't be that long since last video was about 1 hour. This video will be about just 15 to 20 minutes. Then the next video will be again for 1.5 hours. Like that only it will be normally going okay in a flow. Okay. So here, what is this IUPAC representation? See, normally here first you have to write the oxidation. See here, what's happening? This chemical reaction is there, right? But unfortunately, we cannot write that chemical reaction every time in order to say that okay, this is what happening in this cell, this is what happening in that cell, like that at all. We cannot write each and every time. So what IUPAC has found is that they have given a representation. First is you have to write the oxidation reaction. Okay, first you have to write the oxidation reaction. Then after that, you have to put two lines like this, and you have to write here reduction reactions. Okay, reduction reactions. Okay. So in case of oxidation reactions, how it will be? See, here even we'll take it. Oh, okay. See, anode oxidation is happening where Z10 is converted into Z10 plus. Okay. So I'll write this in this color. Z10 will be converted. Here only single line should be written. Okay, is converted into Z10 2 plus 2 lines and reduction, which means that Cu. Okay, wait. See, copper 2 plus is converted into copper. Cu2 plus is converted into Cu. Okay, so yeah, so Z10 2 plus Cu2 plus Cu. Okay, so yeah, this is what is happening here. This is oxidation. Here it is actually reduction. That means this is anode. This is anode, and then this is cathode. Okay, so also for other reaction also. Okay, now we will be doing a one small sum like thing. It is not a sum. Okay, see, now they have given you like this one. That is that Cu is converted into Cu2 plus. Okay, and Ag plus is converted into Ag2 plus. Ag plus is converted into Ag. Okay, see, note these two lines are there, right? These two are actually used to represent the salt bridge. Okay, these two lines are used to represent the salt bridge. Yeah. Okay, so at anode, cathode. Okay, see, in anode, Cu is actually converted into Cu2 plus 2E minus. Okay, so in cathode, Ag plus is converted into, so Ag plus 1E minus, okay, is converted into Ag. Okay, into Ag. See, here 2 electrons is there and here only 1 electron is there. So in order to equalify that, here you have to put 2, here also you have to put 2, here also you have to put 2. Okay, now only these two will be equalified. Okay, now only these two will be equalified. Okay, next is net reaction. So net reaction in sense what we will be doing normally, we will be normally cancelling this electron and then this electron. Okay, then we will be just adding and writing. So that means Cu plus 2Ag plus is to Cu2 plus 2Ag. This is what the net reaction is. So when they are given something like this, then you have to write it like this. Okay, see, 2 plus one of the most important thing that I forgot to say is that, see, this is very basic, that is why I didn't say. I thought all of you would have known. I don't know. Okay, Cu2 plus means this copper. Okay, this copper. Okay, this means actually Cu2 plus means that copper has lost okay, 2 electrons. Okay, then only it will be converted to Cu2 plus. Very basic thing from our class 9th, even we are 9th, 7th, 8th, I don't know from when we are reading it. From our very lowest sections of chemistry when we are reading, right? So that is why I didn't say. But if you don't know, nothing, no, that is not a mistake. Okay, you haven't learned it. That's it. Okay, now only you have got the chance to learn it. Cl minus means chlorine has gained 1 electron. Has gained an electron, and then it has become a Cl minus. Minus means gained, plus means okay, it has lost. Okay, it will be completely opposite. Plus means normally what we'll be thinking, it will be gaining, right? But it's not, it's losing. Okay, perfect. It's very tricky over here. Next is standard hydrogen potential. Okay, standard hydrogen electrode. Sorry, standard hydrogen electrode. Standard hydrogen electrode. So, what is this standard hydrogen electrode? Okay, see, we have to first get the image. Standard hydrogen electrode. Sorry, I am getting that word, potential itself. Okay, so standard hydrogen electrode. I'm so sorry for the screen color change. I cannot find a video. I cannot find an image which has this black color background. Everything is having just white color. So I had no option. I have to do like this only. Okay, see, if you just check it out, this is the image. Okay, so a pure and dry hydrogen gas is there. Okay, so pure and dry hydrogen gas is being passed by these circumstances. Okay, there are a few circumstances that we have to note over here. Circumstances that has to be noted are, okay, pressure is 1 atm. Okay, pressure is 1 atm. Then concentration is 1 molarity. Then temperature is 25 degrees Celsius or 298 degree Kelvin. Fahrenheit, sorry. For Kelvin there is no degree. Okay, so these are those few circumstances. I don't know whether for 298 Kelvin. Okay, or 298 Kelvin. Okay, not degree Fahrenheit. I'm so sorry. So for 298 Kelvin. Okay, so these are those things. I will just write this one formula since I got confused. I don't want you to do that same mistake. Kelvin is equal to Kelvin is equal to 273 plus degree Celsius. Okay, 273 plus degree Celsius. Wait, I'll just check it out. 892. Okay. Okay, so this is for the formula. Just a small formula, you can just take it out. But for ages I haven't used black color. Now only I'm using. Okay, so coming back to the topic. See, this is what the cell structure is. Normally, this is how it will be. Where pure and dry hydrogen gas at 1 atm. Okay, it says here 1 atm. I don't know whether you can read it or not. Okay, so that is being passed inside here, where it is having this copper wire. Okay, it is having this copper wire. This thin line is there, right? So this is actually copper wire. Okay, and this is what the voltmeter is. It is saying, okay, this is V. So this is what the voltmeter is. It is showing some readings in it. Okay, so here is the glass tube. Here is the glass tube. Okay, so glass tube is here. This is glass jacket also they will be saying. This total structure is what known as glass jacket. Okay, and then it is actually also having, see, from here there is a knob. Okay, there is a knob like thing. That is actually known as mercury. Here it has mercury. Okay, and here is the platinum wire. Okay, platinum wire, and here it is being dipped in a solution called HCl, hydrochloric acid. Okay, solution of HCl, okay, which has 1 molarity of H plus ions. 1 molarity of H plus ions are there because only 1 HCl or one. Okay, so this is what the concentration is. Okay, here is actually platinum. Okay, platinum. Okay, platinized platinum foil. Platinized platinum foil is here. Okay, so this is how the structure is totally. I know I've just marked it, and this is a beaker. Okay, this is the beaker. Okay, that's it. Okay, so this is the platinum wire. Okay, so coming back to the concept, I will use this color. I've already used that. Okay, so this is where the thing is, where hydrogen is being passed over here, and then it comes here. Okay, it comes to here, and then here it is hydrogen is coming and hydrogen is going out. That is what is happening. That's the thing that is happening. H2 is coming in and H2 is going out. Okay, so this is what is happening. So here in the anode, see, this total thing can be taken as anode, or this total thing can be taken as cathode. Wait, here I said that E naught cell of this anode is minus 0.76, right? And also over here I said that E naught of this cathode is plus 0.34, right? Yes, right. So how did they find it? How did they find it? By using she. See, either she will be used as cathode or she will be used as anode. This is what will be happening. Either she will be used as cathode or she will be used as anode. So for an example, if she is used as cathode, if she is used as cathode, then they will be keeping another beaker which can be either, see here we are having zinc, right? So then that means zinc will be used as anode. Okay, if she is used as cathode, then zinc will be used as anode. If she is used as cathode, then also you can use copper as anode. Okay, or if she is used as anode, then this will be used as cathode. If she is used as cathode, then this will be used as anode. Like that, they will be just interchanging. Okay, based on the she. Okay, so she is in the cathode. This cell is over here. Okay, this cell is over here. Then there will be another cell. So copper can be here. Okay, copper can be in this anode. Okay. So based on this, first what they did is they first found the voltage of she. So she's voltage is 0. She's voltage is 0 both in cathode and both in anode. My eyes are paining by just looking at this white color. Okay. So this is actually 0, and here over here it will be giving you some value. It will be giving you some value, and that value is what this value. Okay, so always remember that for oxidation it will be negative. For oxidation will be negative. For reduction will be positive. So for oxidation, what it is minus 0.76, minus 0.76. Okay, and for reduction, what it is actually 0.34. Okay. Okay, so yeah, so always remember that cathode. Okay, see here zinc 2 plus is there, so this is oxidation. It is oxidation minus 76. Okay, so reduction plus 0.34. This is something that you have to remember. Minus 0.76 plus 0.34. Okay, so yeah, no. Okay, so A node, D, E anode. So wait, now we will be checking out what will be happening if this is kept as in cathode, and what will be happening if it is kept as in anode. Okay, she used as anode. SHE used as anode. Okay, then she used as cathode. Okay, see, if she is used as anode, what will be happening in anode? Anode always, what? Oxidation will be happening. Okay, actually for a second I forgot. Oxidation. In cathode, reduction will be happening. Okay, carry, like that you can remember. Okay, carry, like that you can remember. Okay, so in anode the reaction is going to be H2 gas. Okay, H2 which is in gaseous state at 1 atm. Yeah, at 1 atm. H2 in gaseous state at 1 atm, okay, is there. So what it will be doing, oxidation will be there now, so it will become as H plus, okay, it will be becoming as H plus, okay, 2H plus in aqueous state, okay, in 1 molarity, like this will be becoming, okay. So in cathode, then how it will be, exactly plus 2E minus, okay. So in reduction, how it will be, 2He plus will be there, okay, plus 2E minus is there, okay, and it will be just going on like this, and it will become as H2 gas plus 1 atm, okay, as 1 atm, okay. So here, if you just check it out, the E0 cell's value, is 0 volts. Here also E0 cell value is 0 volts, okay. If you just check it over here, okay, the platinum over here is actually it doesn't do any job. Hydrogen comes like hydrogen and hydrogen leaves like hydrogen. That's it. So platinum does not do any job. So here this electrode is known as inert electrode. In our NCERT book, they would have given us a sentence, okay, for she they would have given us a sentence that platinum and silver, okay, can be used. Yeah, I cannot find that sentence, but I think I read it once. Somewhere it will be. Okay, I don't know whether that sentence is there or not, or whether in my dreams are read or not. Okay, but I think there is a sentence like that. If it is not there, okay, it's okay. See, platinum will be used as inert electrode. Okay, in some cases it will be inert electrode, in some cases it will be an active electrode. Okay, so it's like this. Okay, so then after this, so since it is actually inert electrode, see, always I personally want to give as much as information as possible to you all. So here I've got a small information while normally researching about all these topics, learning about all these topics. I normally tend to learn something. Okay, if you want to gain knowledge, then automatically God will be giving you knowledge if you do hard work. Okay, so normally in that case, I have learned just only one thing that I want to share to you all. Okay, Daniel cell to calculate. Okay, see, since you have to represent, okay, you have to represent whether it is actually an inert or it is not inert electrode. In that case, what will be done is, so we'll take Daniel cell of copper. Okay, Daniel cell with Cu2 plus with copper and hydrogen. Copper and hydrogen. So what happens is that the arrangement must be, see, the arrangement has to be, in some cases, as I said, that it can be used as cathode, and in some cases, as I said, that it can be used as anode. Not a problem, because in either cases, it's actually, the thing is, in either cases, it is actually zero only. Both if you are using this as anode and also if you are using it as cathode, no problem, it is actually zero only. The volt is zero only. Let it be. What is there? Okay, so since we are going to take this cell itself, like this we can take. Okay, solid bridge, all those blah 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 things that we have discussed is over here. Okay, so now the thing is, in anode, see, as I said that here anode is in copper now, so no, we will take hydrogen as in, okay, hydrogen as an anode. We will take hydrogen as an anode, so that means hydrogen will be going oxidation. That means H2 will be formed into 2H plus also. You can write, but this is not required, so just H plus is enough. Just H plus is enough. Okay, and here also only one line has to be represented. I'm so sorry for the mistake. And here you have to put double line which is representing the solid bridge, and then you have to write the reduction process. That means here Cu2 plus will be converted into Cu plus. Sorry, Cu. Just a Cu. Sorry. Okay, so here what is being used? What electrode is being used? That has to be put into this open mathematical bracket. See, The bracket, if you are putting like this, now then it is known as special bracket. If you are using a bracket like this, now then it is known as closed bracket. If you are using brackets like this, now then that is known as opened bracket. Here it is closed, opened, special. Okay, very interesting, right? Okay, so since here platinum is being used, okay, here platinum is being used, you have to first write platinum. Okay, so along with that platinum, what you have to do is, first you have to put a line like this, and then you have to, okay, then along with that, what you have to do is you have to put a bracket like this. Okay, so this bracket represents that platinum is an inert cathode. Sorry, inert electrode. Sorry. Platinum is an inert electrode. Okay, so that's it for today's video. I will try to merge part 1 and part 2. Then this particular clip that you will not be seeing. Okay, so that's it. Thank you. Bye bye.